Welcome to lesson 1.11. Here we're going to continue our work with vertex form and using it to our advantage to efficiently work with quadratic functions. Alright, so go ahead and copy this discovery problem down, do parts A, B, and C on your own. Make sure you have the graph copied down as well. Spend about 7 to 10 minutes on this problem if you need to. If you finish it in 5, great. Go ahead and then press play, and we'll sort of talk briefly about it together. Alright, I hope that went well. If you struggled, I'm going to kind of give a couple of hints as we talk about parts A, and I want you to pause the video and then go ahead and continue on your own if you all of a sudden have a moment of inspiration when you hear something that I say, because if you're able to do this on your own first, you'll more clearly understand the process and the ease with which vertex form lends itself to creating a function. So the first and most important thing is to remember the vertex form of a quadratic is given by y equals a times x minus h squared plus k. And we remember that these values have a lot of meaning, right? So the a value is the same as it is for a standard form quadratic, and remember it really dictates the basic direction of the function, right? If we have an a value that's negative, right, we know what that does to a function. If it's positive, we know what that does to a function. The bigger the a value, the narrower it is. The smaller the a value, the wider it is, right? We know that h and k represent the vertex, and so notice that we can actually create our function with ease, right? Two of the values just represent the vertex, and so if we can pinpoint the vertex, we're in good shape, okay? So without doing any work, we can actually make some pretty close approximations for h, k, and a, and this is a hugely important step because if you go in and just start solving right away, and let's say you get an answer that you know should be positive, but you haven't thought about it long enough to know that it should be positive, and you make a little error and get a negative value. If you haven't thought about your answers making sense at the beginning and what they should look like, then you're going to be wasting a lot of time going and writing up that answer potentially. So start with the a value. What do we know about the a value? Well, the most glaring thing we know about it is that a negative a value will make the parabola face downwards because it'll take the squared term and make it negative. And if it's positive, it's going to be opening upwards because everything's going to be increasing. Well, this is opening downwards, and so we know that a should be negative. Okay, so one thing that we're going to keep here is that a should be less than 0 or negative. H and k, that's really easy, right? H is the x value for the vertex. If I'm looking here, that appears to be -3, and k, that appears to be 4. So h should equal -3, and k should equal 4, and that's just based off the vertex. Okay, so those are my thoughts. Now let's go in and actually create this for ourselves. So if you haven't already, do this yourself. I'm going to go ahead and move to the next slide so we can really clearly detail the steps that we're going to go through. And once you've created your function, go ahead and test it out on wolframalpha.com or your calculator. All right, so if we're going to write a quadratic function in vertex form, we obviously want to know what vertex form is. Now, a hint, preview to what's coming soon, thinking about what's easier to write the quadratic function in. Is it easier to write it in standard form, ax squared plus bx plus c, or vertex form? Well, knowing that h and k are the values, the x and y values of the vertex, it really actually makes the vertex form a lot easier to use when we're trying to write a quadratic function based on a graph. So that's a key point to remember. If you're ever given a quadratic function and you have to create an equation for it, you want to use vertex form. It's going to be easiest. So we've already taken care of step 1. We've hypothesized what a, h, and k should be for this situation, so you can go ahead and rewrite those if you want. Now, once I've hypothesized, notice that in order to write my function and define it clearly, I need to find the a, h, and k values. That's all I need. Once I have figured out what those are, I have my function defined. Well, let's think about the easiest ones to figure out. That's going to be the vertex points, h and k. So we'll find and label the vertex, which in this case is at the point -3, 4. So those are my h and k values. So h is equal to -3 and k is equal to 4. Okay? So once I've determined them, I always want to input them into my function to see what I've got so far. So I always want to take note of what I have so far. So at this point, I have the function f of x is equal to, I don't know what a is yet, but I already know what h and k are, so I should be off to a pretty solid start. So it's x minus h. H is -3, so minus -3 will be +3 squared, and k is 4. Okay, I'm in pretty good shape. So at this point, what's the last thing that we need? Well, we need to find the value of a. Okay, so I want you for a second to pause, think about what could you do? What information do you have from your graph that could help you determine exactly what the a value is? We already know that we think it should be negative, but how could you figure out the exact value of a? Alright, so here's what I want you to consider. Do you know any other points that are on this graph for sure? And if you look at it, there are some that are pretty clear, right? In other words, some values, some points that are right on easy to determine values. Like this is pretty clearly -2, 3, right? They're integer values. This is pretty clearly -5, 0. This is very clearly -1, 0. Well, these are x and y values that you know work for your function. So what if you plugged in an x and a y value that you know have to be on your graph? And that way, well, if you plug in an x value and you plug in a y value, well, all you'd have left that you don't know in that equation would be a. And so you could solve for a. Okay, so in order to find our a value, what we want to do is find and label a point, an xy coordinate point on the graph. One note about this, what kind of point do we want to pick? Do we want to just pick any random point? No, let's pick a nice point that is really easy to plug in and use. In other words, it has integers for both the x and the y coordinates, so I've labeled a couple here. Next, we want to substitute that point, in other words, substitute in the x and y values into the function, and then we can solve for a. So let's go ahead and choose a point. In fact, I would advise you to choose one on your own. Go ahead and find your a value, and then I'll choose one. Maybe it'll be a different one, and we'll see that we'll get the same a value. I'm going to go ahead and choose this point here, -1, 0. I think it's going to make it the easiest it possibly could be. So I'll go ahead and plug that in. Well, while I'm doing that, what I want you to also consider is why could we not plug in the vertex? Why couldn't we just plug in this vertex point? So the vertex, if I plug that x value in, that -3 in, notice that that would give me -3 plus 3, which is 0. 0 squared is 0, and 0 times a is 0. So I would actually be getting rid of the a by multiplying by 0, and so it would be impossible for me to solve for it. So with that being said, I've input my x and y coordinate point, -1, 0 into my function, 0 for my y value, -1 for my x value, and now I can go through and I can simplify and solve for a. So I have 0 is equal to, now -1 plus 3, that's a value of 2, and 2 squared is 4, so I'll have 4 times a plus 4. And now I just need to solve for a, and so I can do that by subtracting 4 on both sides and then dividing by 4 to get that my a value is equal to -1. So my a value is -1, and at this point I have completely discovered all of the parameters, a, h, and k, that I need to clearly define my function, and so now I can go ahead and write out my function. Alright, so I'm going to go ahead and complete my function. I'm going to do this over here so that I have a little bit of space. And so my function f of x is going to be equal to, a is -1, so I can just write a negative sign there to represent the -1, x plus 3 squared plus 4. Now, I want to check and make sure that this is the correct function. So there's a couple ways that I can do this. The first is just to go back and remember when I hypothesized what my a, h, and k values should be. I want to make sure that those are in line with what I ended up finding. So I found that my a value was -1, and remember when I hypothesized I said a should at least be negative because this is an upside down parabola or a downward opening parabola. I said that my h and k values should be the values of my vertex, my coordinate points for my vertex. I had -3 and 4, and certainly that's what I got. And so this all makes sense. And if I wanted to further check, I could go construct a graph either on my calculator or Wolfram Alpha, and I would see that I get exactly what I have graphed here. All right, I'm going to give you a couple to practice with, and then I also am going to point you in the direction of the couple of videos that I put up on the circle line task as well as the medieval archer task, if you want to take a look at those. All right, here are a couple problems for you to do on your own. Make sure that you are not just going through one time, but also making sure that you're checking for that your values make sense, and that you're completing both parts A and B of this question. And don't forget to look out for the task solutions that I'm going to put up.